These notes are in the Unit 2A packet on inequalities, and it's topic 4, solving linear inequalities. We solve linear inequalities exactly the same as we solve equations, with one very important exception. And the exception is when we multiply or divide by a negative number, we have to do something special. We have to flip the symbol. So make sure you get this down. This is a really important exception. We have to flip the symbol. So let's take a look at our first example. So we're solving this inequality the same way as we would solve an equation. Take our line down the middle. We're going to balance out by adding 4 to each side. So I have 36 is less than 3x. I haven't multiplied or divided by a negative, so I don't need to worry yet. I'm dividing by a positive 3, so I get 12 is less than x. I didn't multiply or divide by a negative, so I don't need to worry about anything. If I think about that on a number line, that means that x is greater than 12, and I'm going to use my open circle to represent the 12, and all x values would have to be greater than 12. So if I were to write this verbally, I would say x values greater than 12, and symbolically I would say x is greater than 12. In our next example, I'm going to solve this the same way I would solve an equation. I'm going to subtract the 6 from both sides. I get negative 15 is less than or equal to negative 5x. My 6 and negative 6 cancel. And then I divide both sides by negative 5, that coefficient in front of the x. And this is my big exception. I have to flip the sign. So when I have 3 and x, after I simplify, this sign becomes greater than or equal to. So my final answer is that my x values have to be less than or equal to 3. Sometimes I prefer to write it like this, x less than or equal to 3. I find it easier to know which direction to go. So I'm including my 3 on my number line, and all values less than or equal to 3 will make this inequality true. And I can write values less than or equal to 3. Our next one, or our last one, I notice that I have a smaller x value over here, so I'm going to add x to both sides. I have 3x plus 4. My symbol stays the same. I didn't multiply or divide by a negative. I subtract 3 from both sides. I subtract 4 from both sides. I have 3x less than 3. I still haven't multiplied or divided by a negative. And when I divide both sides by 3, I get x less than 1. On a number line, that looks like not equal to 1, but all x values that are less than 1. Verbally, that means that x is less than 1. And symbolically, I can just leave it as x less than 1, or if I want, I can write that 1 has to be greater than x. As promised, here is your explanation as to why do we have to flip the sign when we multiply or divide by a negative. Well, if I look at a number line and I compare the number 1 to the number 5, I would say 1 is less than 5. But if I were to take those values negatives, if I take negative 5, that is a flip over the 0, and it comes over here. The 1 flips and comes over here. So if I were to multiply each of these numbers by 1, notice that now the negative 5 is less than the negative 1. In other words, the -1 is greater than the -5. So here's how that works when we're using an equation. If I write, inequality. If I write the original inequality, 4 is less than 20, and I divide by 4 on both sides, I get 1 is less than 5. This started true and it ended true. However, if I take the same original, 4 less than 20, and I divide both sides by -4, then I get -1 is less than -5, which is false. -1 would be greater than -5. So this is why we have to remember that when we flip over the 0, when we multiply or divide something by a negative, that sign flips the other direction.